Today we are going to discuss experiment number 1. The title of the experiment is Step Response of a Given System. Here we have a system, thermometer and thermowell. Thermometer is a system which is used to measure a temperature of a given system, and thermometer is also an instrument which is used to measure. In thermometer we don't have a resistance. In thermowell we have a resistance. Thermowell means we have a well which will be filled with oil and you will be keeping the thermometer here. So therefore that is a thermowell. And here we are going to, what is the aim of the experiment? To determine time constant of a given system. What is it? Thermometer and thermometer. It is total system. And we are going to understand what is a type of a response is given, and what is a type of a input is given, and what is a type of a response we are going to get. So here we are talking about a step input. In this experiment we are studying about a step input, how the step input will be used for a given system. Suppose if you see the step input, this is 0. Initially there is no disturbance of a system. Suddenly we are going to give a disturbance and the final value. So therefore this will look like a step, therefore it is called a step input. After the experiment, if you see, your step response will be look like this. So this is a maximum value of a response. It is a maximum value of the response. And whatever the magnitude of a system will be, difference between this and final value. This is called a magnitude. How much magnitude? Suppose if you are starting with a temperature of 30 and reaching a temperature of 60, what is your magnitude? 60 minus 30, 30 is a magnitude. So therefore what is the amount of input you are going to give? So therefore we are going to understand what is a step response. For the first order system, you know that, so output by input, x of s and y of s divided by x of s is equal to kp divided by 2s plus 1. What is kp? Kp is a gain. Gain is nothing but a sensitivity of the system. So that will decide how fast your system response is. And also based on that, I am going to decide about the magnitude. Magnitude of the change or the disturbance will be decided by Kp value. Kp is the sensitivity of the system. So if it is not known, usually we will take this as a 1 divided by 2s plus 1. So therefore 2s is a time constant. So therefore I am going to calculate a 2s. What is x of s? This is output and this is input. So therefore x of s is a magnitude of a change. What is magnitude of change? Step 1 by s. Suppose if you are giving a magnitude a, then it is a by s. Therefore your magnitude of a change is a by s. Suppose if you put a by s here, I am going to take this a by s here. Therefore kp a by s 2s plus 1. Suppose if you solve this, the equation to determine the step response of a given system will be y of t is equal to a 1 minus e to the power of minus t by 2. Why I am using this equation? This equation will be helpful to identify what is the response of the system. If the magnitude of a step change a is given, then I can easily calculate the response at any instant of time by using this equation. This equation will help you to determine what would be the response after some time. So therefore y of t is equal to a into 1 minus e to the power of minus t by tau. So t is a time, tau is a time constant. You are going to know what is the time constant of a given system. Okay. So today we are going to discuss about first order system. So this is experiment number 1 in a process control lab. So this is first order system in process control. Look at the response and with respect to temperature. First order system. This is an experimental setup which consisting of thermometer and manometer. As you know, thermometer is treated as a first order system and manometer is treated as a second order system. So what are the characteristics of a first order system? The system which represented by first order differential equation, then it is said to be a first order system. What are the characteristics? If you look at the characteristics of thermometer will have a capacity to hold any energy, mass and momentum. You can see here what is a mass, and bulb of a thermometer is containing mercury, that is the mass, and when you get heated, it will start expand thermally and it will start moving through the column. So therefore expansion is also there and movement is also there. Therefore if any system will possess these characteristics, then it will be called first order system. So what is the characteristics of a first order system? Characteristics of any system will be depends upon how fast the response is going to be observed. It is called a time constant. Time constant is nothing but how fast you are reaching a maximum value of a response. So if you see as a first order system, the first order system is with a step change. It is 0 initially and it is increasing, and again it will be a constant. Therefore this type of a system and this type of a response is called a step response. So therefore we are going to study the step response of a thermometer. So this is a thermometer which should be having a bulb. So bulb will be dipped in a different temperature. As soon as you are dipping in a different temperature, it will show the reading. So this will be used to calculate the response of a system. The input is any input which will be given from outside. Output is the nature of the system which will respond to the given input. So therefore you can see here, so this is a type of a response. You can see this is a step input, and if you come here, it is a sinusoidal input. Sinusoidal means it is a cyclic and it is step. So we are going to discuss about a step response of a given system. So therefore the today's experiment is to understand the step response of a given thermometer. Here the system is consisting of thermometer. I'll show here. So this is top view of equipment, and if you look at from the side, this is a side view of a system. So where you can see here this is an inlet. You can see here this is an inlet, water is entering here. So this is a level of a tank. So this is a very small tank in which we have a heating element. This heating element is going to heat the contents inside it. It is water and it will flow out. So this will be connected from this pipe. It will be connected outside. So this is outlet of water will go through this. Okay, you got it. So this is an inlet which will be connected from the tap. You can see here. So this is connected from the tap, and the water will be entering here. Water will be entering here, and then it is leaving from the top. And we have on and off controller in the front. So this will be used to protect your device, since the heating element is very powerful, and volume of water will be very limited. So therefore what I'll do, I'll keep 30% on and 30% off. Means 30% your heater will be on, and after 30 second it will be off. So therefore this is a setting. So 5 means it is 30 seconds on, 30 seconds off and on. So which will prevent damage of your heating element. And you have a mains over here. If you switch on, so it will give a heating to the coil, the heating power to the coil. And so this is a simple equipment, and it will be having a power cord over here. So switch this and switch the mains, right? And when you see here, after switching that main, if you switch, you can see here it will glow, means power is connected. And then you can see here it is on and off, means it is 50% on and 50% off. Okay, and again come back here, this is connected, outlet wall is connected, you connect the outlet wall. Okay, and when the water is full here, you close this knob. So this is a knob, this is open. Okay, you can see the level of water. You can close it, means it is full, the level of water is up to here. And then there is a provision to measure a temperature. See here, you have a provision for thermometer. If you want to keep it thermometer, directly you can keep it. So this is a thermometer, and once if you keep it, you can measure the temperature. You can see here temperature can be measured like this. Okay, and here you have a thermo well. You can see here there are one more provision, it is a thermo well. Thermo well means, so this is a well which will be used to keep the thermometer. So therefore this is thermometer, and this is thermo well. Thermo well means thermo well will be having a resistance. So you have a resistance of this metal wall. So where the thermometer will be, this one. Okay, so you can use both thermometer and thermometer. It is one is without a resistance, other one is with the resistance. Okay, so therefore you can keep the thermometer and then start the experiment. The mains, as you switch on the main, and this is a main button for the experiment. When you switch on, your on off controller is set for 30 seconds on and 30 seconds off. And what it does, for first 30 second cycle your heater will be on, and next 30 second cycle it will be off. So it is done to prevent the burning or damage to the heating coil. If you see, the capacity of your coil will be high, and as you compare the capacity of the water holding, it is very less. So therefore it will be kept 30 seconds on and off a period. So therefore you can see here how it will change. It will give a sound. It is a change of a cycle, 30 second on and 30 second off. Just it is now off cycle. Just look at it. It will come to this position now. Okay, see here, it came here. Then again it will go there. Okay, and when it will be heated, you can see here. The water will start boiling. As soon as you will get a vapors and boiling sound from the top of this, you suddenly inject the thermometer. You can see here. You can now, I'll show. The water will start boiling, and before start of the experiment, you have to keep your thermometer in a cold water. Okay, I'll keep this thermometer in a cold water. I'll keep that in a cold water. So we'll wait for water to boil. Since it started on heating, so this is a thermo well, and this is a thermometer. Okay, it is getting heated. You can wait for one more cycle. You will see the vapors here. I hope you can see how the water will start boiling. Yes, okay. See here, it started boiling. As soon as it will start boiling, suddenly you have to inject the thermometer here and note down the reading for every 1 second. Okay, so note down. So whatever the temperature is rising, that need to be noted down. And okay, note for every 1 second, one has to read and one has to write, and wait for the maximum temperature rise. See, you can look at it. So it has reached the maximum temperature. Okay, so when you dip your temperature back to the cold, then it is a negative step. So here, this is a negative step. Negative step means the temperature has reached the maximum and you are getting that temperature back to the initial temperature. Then it is a negative. For your experiment, what you have to do? You take the thermometer temperature to the cold temperature and suddenly you have to dip into the thermometer and note down the temperature rise in every 1 second. One has to read and one has to write. So this is the end of the experiment. Okay, and note down the values and do the calculation as is shown in the lab manual as well as a tabular column. To calculate a step input, what is the step input? Step input is y of t is equal to a into 1 minus e to the power of minus t by tau. So we are going to verify this, and also we are going to calculate time constant of a given system. Suppose if you look at the system, we have a heating coil over here inside, and water is filled up to this, and temperature is supplied through this temperature in that temperature. So due to this, water will start boiling, and then I am measuring the temperature by this provision. So we will be having a thermometer and thermo well. Okay, I am going to calculate what is the time constant of thermometer and thermo well. So this is a system. And what is the measurement? As soon as the water will get boiled here, measure the temperature, and for every 1 second of time, note down the temperature. How you can note down? One should read and other should write the reading. Okay, it is very fast because expansion of a mercury will be very fast. Okay, so therefore one you should do randomly. You see whatever the value you are looking at, you tell that value and you can write it. So therefore, before start of the experiment, you take your thermometer and keep in the cold water. Cold water means tap water. Take a tap water and then you note down what is the initial temperature. And final temperature means once it boils, and after conduct of experiment you see what is the last value of a temperature, that is the final temperature. These are the observations we have to make. Okay, see here, once the experiment will start, we are going to note down 0, 29 means it is a before start of the experiment, means it is an initial temperature, and these are the values. At last somewhere some value you will be getting 98. Okay, so this is a value of observation. These two only green, whatever the green written, it is a value of observation. So this predicted will be shown in the calculation. This is all about the conduct of experiment. Boil the water. Once the water will boil, insert the thermometer, note down the reading, temperature versus time. So this is all about conduct of experiment. And what are the observations? Observations is only initial temperature and final temperature. Okay, so therefore whenever you are using a temperature measurement, we generally use a thermometer. So what is important for a chemical engineer is to identify how fast the system will give a response. Faster the response, better. Slower the response, you will get a delay. Then you will be delayed by every time. Definitely this will be accumulated and it creates an error. So therefore that will be calculated as a time constant of a given system, tau. What is the time constant of the system? The maximum ultimate value of the system will be reached at a first time is called a time constant. So therefore ultimate value of the system for the first time is time constant. How fast it is taking to reach ultimate value of the response is called a time constant. But when you are talking about a time constant of a given system for a step change, we generally write it is a 63.2%. So it will be 63.2% age of ultimate value of the response, because minus t by tau. So because you have a value of 1 minus e to the power of minus t by tau, right? So 1 minus e to the power of minus 1 by 1, suppose 1, then this will be 63.2. So means it will take 63.2 percentage as a 1 tau. So similarly you can calculate t 2 tau. 2 tau will be 84. Okay, so therefore it is for the first time. One time constant is 63.2%. I think you have already discussed in your theory class. Okay, 63.2%. So conduct the experiment and note down the value and coming to the calculation. Very simple calculation. Step change is what? Magnitude. Step is magnitude change. Step is this initial to final. So this is a magnitude of a change. So 98 is a final value, 29 is a first value, 98 minus 29 is 69. You check. Okay, I have written okay. And what is the value of 63.2% of a step? So therefore we have to calculate what is the 63.2% of a step. It is 0.632 magnitude. It is nothing but a final minus initial magnitude of step plus initial temperature. Initial temperature should be added. It is not from 0 because your value is started from 0. Temperature of the room is 29, therefore plus 29. Therefore value of 63.2% is 72.06 degrees centigrade. Theoretical predicted temperature is given by theoretical initial temperature plus step change. You can see here step change is nothing but a 1 minus e to the power of minus t by 2. I have already shown this response because y is equal to a 1 minus e to the power of t by tau. See here, same thing. Okay, so that equation. So therefore initial temperature should be considered because it is not starting from 0, it is starting from a 29. So 29 it should be added plus step change is 69, 1 minus e to the power of 1 minus t by tau. So what is tau? So before adding here you have to calculate a tau of a system by plotting a temperature versus time, and then you plot it. So you get this, and 63.2% you locate and cut the graph and come down. This is the time constant. This time constant is 1.6. You add here and it is 61.06. You can look at it. So for first value of 42, this is 42 minus t is 1. For 1 theoretical actual temperature is 42, theoretical temperature is 61. You can see here initially there is a error. As you go on predicting the value, it will approach the same value at the last. So therefore initially lots of disturbance will be there. This equation is unable to predict initially. Later this error will be eliminated and you can see this value will be predicted accuracy of the equation will be high at the end. So therefore similarly you do it for thermometer as well as thermowell. Okay, so as I have discussed in experimental setup, so where it is shown a thermometer and thermowell, there are two provisions. First you conduct this experiment as well as thermometer, and so you have to do both the experimentation. So here you have to plot one actual as well as theoretical. Actual versus this, theoretical versus this. So for actual, what is the time constant? For theoretical, what is the time constant? So after that you can tabulate the values and do the result. So the step, what is the result? The step response was studied and we have determined theoretical temperature of a system, and also we have predicted so time constant of a thermometer as well as thermowell. So this is all about experiment number 1.